So were we, and we got 3 questions on homework. Let's do it again.
I'm going to record since Anna Martin's not here. Hi, Anna. We hope you feel better. Everybody tell Anna we hope she feels better. Okay. We talked about slope field. Do you remember what slope field was? Where we do a little teeny tiny piece of a line for each. So just as a review, let's do a quick slope field. Let's say we'll do an easy one. X plus y equals, no, just kidding. dy dx equals, I don't know what I'm thinking. Dy dx equals x plus y. Catch a slope field. So this says that the derivative is x plus y. So everywhere I go on a coordinate plane, we'll just go to 2. At 0, 0, what's the slope? This is the point 0, 0. The slope would be 0. What's a 0 slope look like? Horizontal line, right? So this would just be a little piece of a horizontal line right here. Usually you just can't see it for that one, and they know. They can't see it. For on the axis. Just 0, 0. Yeah, on the axis. How about 0, 1? 1, so it's going to look something like that. How about 0, 2? Little steeper. This is telling me what the slope is. Dy dx is slope. So it's saying the slope is, and you take the x and you take the y and you add them together. They give you an equation for the slope. And so then you're just sketching a little teeny tiny line that has that slope. Yes. Yes. How about 0, negative 1? Negative 1. So this same steepness, but negative. So maybe something like that. And then 0, negative 2. Negative 2, which is even steeper. And then as I move on, and I can do this for every single point, right? 1, 0. 2, 0. Even steeper. Do I need to do all of these? At 1, 1, it's 2. How about at 1, 2? So even steeper. That's way bigger than that. Okay, thanks, Dozier. Okay, it is. But still, you get the point. That's a little joke. What else do we do? What? Yeah. That, and we evaluated indefinite integrals using antiderivatives. So if we had something like, yeah. Is it the last? Oh, no. Sorry. We're on unit 6, so we'll do the full unit 6, and then we hit we actually won't do the full unit 6. We'll skip 1.5 lessons, and then we do a piece of 7 and a piece of 8 to make up that unit 8, and we're done. The others are BC in the book. So we're almost done. All right, so then we did the indefinite integral like this, where we found the antiderivative. How do we find the antiderivative of that? That's right, plus 1 and divide. So this would be what? X to the 5th minus. Y'all did this with the last unit. Y'all got this.
Oh, no, it's, yeah, that's the negative 10.
It's 10.
Yeah, I don't
so it is. All right, so all that was what we did before we did the unit that we were supposed to do first. So let's talk about U substitution. Yep. All right, more definite. We will probably camp out at U sub depending on how well y'all take to it for a bit. Where is it? What did they say? Because she told me. I think the easiest way to show you this is just to jump into it. Sorry, erase your F of X. Logan, evaluate.
Okay. Alright.
Antiderivative.
Antiderivative. Plug in.
Plug in what?
Whatever the value is.
It's an indefinite. It's not definite. I don't have bounds.
So you don't have to plug
So
in.
the antiderivative, what is it? 2x?
It's 3x to the third.
But look, I'm multiplying. Is there a multiply rule?
Yes.
No. Remember that trick question that was there's not a multiplication or a division? So you don't have enough knowledge to do it right now. What? Why do you read at me? Okay.
Yeah, I know how to do it.
What if I'm gonna sub this out. This is what we call U substitution.
Sub it out.
Do you see that there are two functions contained within here? Function 1, function 2. Agreed?
Oh, wow.
I'm going to let U be one of the functions. And the way I decide which one I'm going to let it be is I look at which one I kind of have the derivative of, and then I'm going to use the other one for U. So in other words, if I took the derivative of 5 plus 2x cubed, I don't have the constant out there, but that's okay. I'm going to worry about that in just a minute. So what if I let U be 5 plus 2x cubed? Just wait. What would... I'm letting U be this function, and I'm going to think about this as being the square root of a function. I'm going to let 5 plus 2x cubed be the function. The more you do these, the more you'll see it. Let me just stay with me for just a minute. What is the derivative of 5 plus 2x cubed? 6x squared dx. Because remember, if I take the derivative with respect to another variable, I have to follow it with a d, whatever that variable is, okay? That implicit differentiation. All right. I did. All right, now watch what happens. I let 5 plus 2x cubed be u, okay? Now, what's happened is my du is not completely contained in this integral. Do you see that? But as long as it's just a coefficient I'm missing, I can force it to be there. In other words, what 5x? The 5, because the derivative is just 0 there. Okay. Watch, you'll see why we're doing this in just a second. All right. I'm missing the 6. So if I threw a 6 there, would you agree that everything, the u and the du, is completely contained in this integral? Okay. I'm going to counter this 6. What could I multiply 6 by to cancel it out? 1 over 6. So I'm going to counter it with a 1 over 6 out here. Is that what you said?
He said 6.
Oh, that's okay. I thought he said a 6. He said a 6. You just didn't hear the. He said a 6. Okay. Now, let's rewrite this integral using u's, okay? Watch what I have. 1 over 6 times the integral, the square root of u, du. Do you agree? Because I could rearrange this. Square root 5 plus 2x cubed. Look at what du equals. Logan, this is hard. Pay attention. This is hard. Okay. Can everybody see what I subbed and where I'm, even if you can't, okay. What does du equal? So I replaced the 6x squared dx with du. I'm subbing it out is what I'm doing. Why is the 1 6 there? Because I had to account for this. I had to account for this 6 being here. So I added this 6 here, and whenever I did that, I had to counter it with 1 6. It wasn't part of the initial problem. The original problem was x squared times the square root of 5 plus 2x cubed dx. Okay. What is the can you now find the antiderivative of the square root of u? Yes. Because that's an add 1, divide by what you get, right? So this is really 1 6 times the integral of u to the 1/2 du. Agree or disagree? Agree because it's right. Okay. Now find the antiderivative of u. What's the antiderivative of, well, u to the 1/2? This 1 over 6 is still here.
2 over 3. Good.
Because it's indefinite, right? I cannot forget the plus c.
Oh my, plus C.
All right, because this is the integral of that. Whenever you take the integral, the du goes away. Maybe I should have started with a little bit easier example. Okay. Okay. It is. Logan, what was u? What was u?
5x, or no, 5 plus 2x squared.
Remember, u was 5 plus 2x cubed. So I got 1 over 9 times 5 plus, what did we say? 2x cubed to the 3 over 2 plus c. Now I have found the antiderivative. If you went through and found the derivative this way and chained it and everything else, you would come back to what you started with. We're going to do plenty more.
Hold on.
Let u be the highest degree. Let u be the highest degree function. That's the easiest way I think to remember.
You're telling me you don't know what happened?
If you're dealing with polynomials, let u be the highest degreed. But you always want you want to find what you could take a derivative of and it be present in your integral. I'll show you exactly what I'm talking about. These take practice on recognizing the u and the du. Where did the what go, Sonny? What did you ask? X squared is part of this du here. So whenever I replace the du, the 6x squared with du, and then I integrated. Anyway.
Yeah, but you didn't even use it. Yeah, yes, you then
You'll have,
because
I used the U.
the u is 5 plus 2x to the cube, or 2x cubed. And the du is the 2x squared.
Yeah, the you just isn't there.
Yes, it is.
It is there.
It's
You
at the
just have to-
beginning.
Yeah.
I'm talking about anything right now. Hey, are the rest of the lessons like this?
Hard.
They can do a pancake.
Oh.
Like for a week.
They just take practice.
Don't you sit.
We're gonna do U sub today, tomorrow, possibly another day. We'll see how long.
Do it all week, because I'll be sick.
Look at this one. Kenzie, you got this?
Oh, would you look at there? Yeah, I saw this one. It was something that's something behind it. Why is that?
Can you find the antiderivative of this one? Oh, this is worse. All right, we need to think about what we can find the antiderivative of so we know what to plug in for our U, okay? Can you did you see him? Okay. Anyway, okay. Can you find the antiderivative of this the way it sits?
No, you have to find a u.
You can't do that. Like this.
Are you gonna make me chronicle this?
No.
We're used to it.
We're U subbing.
Oh.
Which one do you see a derivative of the other one contained within the not e, because derivative of e to anything is e to something. Sine and cosine are derivatives of each other, yes? If what? No. 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 Okay. If you, let's just say, I'm going to pick the wrong one to show you what happens just in case. Let's say you were sine x, right? Don't write this one down. Don't write this down. If u was sine x, that means du would be what? Cosine x dx. That means I would have the integral of u e to the, it's not du because it doesn't have a dx hooked up top up here. So I would know, wait, stop, reverse. I did something wrong. I chose the wrong thing, right? What did you say? So you say e to the cosine x. Don't write this down either.
If you can't do it, then why'd you give it to
Say it again. If it's just cosine x, if it's just cosine x, split, you can't split it up this way.
That's exactly what you're doing. You're splitting the e with cosine x.
I'm not splitting it up. Watch what I'm doing. If I let u be cosine x, what is du? Negative sine x dx. Is everything contained within my integral? What's missing? The negative. I can make that happen though, because if I put a negative here and counter it with a negative here, I haven't changed the value of anything, right? Two negatives make a positive. Wait. Okay.
You're killing something.
No, I'm not killing anything right now. All the kittens and the puppies are safe. What? In the integral. So anything that's not contained in here, put it. But we're only looking at numerical coefficients, not functions themselves. If they're not contained, yes. The U? Until you get used to seeing it, it's probably more of a guess and check. I always look and I say, which one do I have a derivative of? And in this case, I had a derivative of both of them. Like, the two functions I see here are sine x and cosine x. Those are my two functions I'm looking at. One of them I need to make u, and the other one, yes. So this is going to be negative the integral e to the u du. That becomes a super easy integral for me too. All right, what is the antiderivative of e to the u? E to the u. So I've got negative e to the u plus c. But because I started in x, I have to finish in x, so I'm going to replace the u with which x? Cosine x. So it's negative e to the cosine x plus c. Because du is negative sine x. Okay. Okay, let me rewrite this and show you. All right, let me show you this because several of you are asking where did some of this come from? Times negative sine x dx. Logan. If I just change the order is multiplied, right? I just flipped it around. Then do you see that what I have is this is u, right? And then du, it says, is negative sine x dx. All of this becomes the du. Because I did double negatives. I did a negative here to account for, that's where this negative is coming from. But to counter it, I had to put this one. You always have to counter it outside, bless you, outside the integral. Because whenever you take an antiderivative, the d whatever goes away. That's part of the integral. Yeah. Yes. It's contained within the integral. Yes. Yes.
Oh no.
So you look at which one has the derivative of the other one contained within the integral. And then you just have to kind of think through it. Then it's the wrong view. Okay. It's not really dropped, it's just anti. Because once you're done, in the end, you only can have x's, you can't have u's. What? No, that's right.
Why is this wrong?
You don't have to do that here because, no, but whenever this accounts for all your chains and all your everything else whenever you take the derivative there. I know that one's right because the answer's right here. What? Well, then I've been doing calculus wrong my whole life.
This would be actually doesn't know. Oh, yeah, really good. I was doing this in my. Yeah, let's see it. Nothing like no. This would be actually good.
Mark said go.
Division is.
Butter. I only see one other function contained within the function there. I only see one option for u, in other words, is what I'm saying. It's in the denominator. Tell me another way to say cosine, 1 over cosine squared. Secant, right? Secant squared. Do you agree that this is the same thing as this?
Sure, if you want it.
But then there's only one function.
Well, this is the secant up. This is a function because something's being done to the x, right? And then the secant squared. So what if I let u be 2x? Well, what good? Okay, yes, if it's a polynomial, but this is a trig. If I let, if,
So you're just going to make it x, and then you're going to try to find.
what?
You're going to find it.
Du is just the derivative of u with the dx that follows it. So 2 dx. Why am I letting u be 2x? Because I know that secant squared is the antiderivative of what? Tan x. Tan x. I know that secant squared is the antiderivative of secant squared x is tangent x. So I know I can move backwards there. What I can't move backwards on is this 2x right here. So if I let u be 2x and I let du then would be 2 dx, then that means I'm finding the integral of secant squared u du, but what am I missing? The 2. And so I counter that out front with a 1/2.
Why do we count that?
Because this du had to be 2 dx. And I had a dx, but I didn't have a 2. And if I add a 2 inside, I have to put the reciprocal of it outside. So it'd be 1/2, that stays outside. What's the antiderivative? And I really don't need this anymore since I got du. Tangent u plus c. What's u? 2x. This is accounting for your chain is what this is doing. Take the derivative, go backwards on this. Take the derivative of that. Because I replaced with du, and du contains, no. That's why I scratched it out. I took this 2 and this dx and replaced them with du.
Oh.
Because that's what du is. Because I couldn't just throw that 2 inside all willy-nilly and change the value. Instead, I had to put the 2 there and then counter it with a 1/2. Remember those integral properties that they can be inside or outside and have the same value? 1/2 times 2 is 1. So if I put this 2 here, then I could multiply by a 1/2, and it's really like it hasn't changed the value of anything. But I need the 2 in there so I can have my du inside. So what's outside keeps following it down, okay. Yes. Now, if I took the derivative of this just to show you that this works, this is kind of like whenever you learn to factor and you're like, how in the world did I get here from my polynomial that I started with? But if you FOILed out, it came back. Same thing here. If you take the derivative, golly geez. If you take the derivative, Logan, what's the derivative of tangent? Secant squared, that's probably y'all's breakfast. Remember, whenever I do the trig, I'm going backwards to show you that it works. And then you have to chain it. So what's the derivative of 2x? 2. What's a half times 2? Is that what I started with? Yes? Yeah.
Anna, she actually just say she just told us that off camera. I clipped that and she wasn't recording. Not even at it. Also, she said, if you bring your pair of socks, you guys can
Absolutely. All right. Those of us doing calculus, Kinsey, what did you let your u be? 3x, which means your du is 3dx. So I have everything contained, but I am missing, what am I missing inside? A 3, right? So if I do a 3, I counter it outside with 1/3. So, somebody help me explain this slave. I don't know. Okay, look. I have to have all of this inside, right? I have the dx. I did not have the 3 that goes with the dx. So I put it inside. But I can't just put that inside and change the value. So instead, maybe, Logan, get your stinking mind out of the gutter. Nothing. He said nothing. Maybe if I write it like this, Slade, it'll help. But there is a coefficient rule that says that if I multiply, I can pull that outside. So now I have 1/3 times the integral. I'm just going to keep doing. What's the antiderivative of sine u? Negative cosine. So I got 1/3 times negative cosine u. Why? Derivative of cosine is negative sine. So the derivative of negative cosine will be positive sine. What is u? 3x. So I've got negative 1/3 cosine. What? Antiderivative.
Oh my gosh, so
Antiderivative.
Wait, BBL stays. What's the homework?
That's as far as you got.
I know that far except for the language.
Why are you starting? Yeah.
HW time, baby.
We're doing several more.
I'm gonna ask my trainer. Which one? Why does Francis beat his brother? Yeah. That's what they beat him with? Francis, future brother. What? DTS. Wait, what are the numbers? You know what DTS is? I thought we were the numbers. One more. What number is that? What number is that?
This is a little bit of a trick one. Trick.
Oh. Oh. Oh, the derivative is going to be 4.
You know the antiderivative of tangent?
No.
Derivative. Y'all are thinking derivative. What's the antiderivative? What did you say? Did you say you have to replace the tangent with sine and cosine? Is that what you just said?
Not right.
What'd you say? Did you? Sine over cosine? Somebody said it.
Good job.
Agree or disagree? Do you understand? Shut up, Logan. Logan Freeman. Do you understand why I had to rewrite it?
Yes.
I do not know the antiderivative of tangent. If you look on your sheet, on the integral side, there's not an integral of tangent, right? And if I look on this side, none of them equal tangent. So I had to try to write it another way. But in writing it another way, luckily, it used just sine and cosine, and I can find a derivative there. So now the question is, what should I let u be? Okay, so if you let u be 4x plus 2, Logan, if I let u be 4x plus 2, I'm just going to have sine u over cosine u. And you still don't know the antiderivative of that. What if I let u be the cosine of 4x plus 2? Because I'm looking at, I can't pick 4x plus 2 because that would give me a du. That would end up being sine u over cosine u, and I'm back in the same position I was in of I don't know what the antiderivative of tangent is. So then it's which one do I have a derivative of? Well, there's sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine. So I could use either one. But what I want to make sure is that I have my du completely enclosed. So if I let it be sine, then my derivative would be cosine, right? And cosine's in the bottom. I can't have my du down there in the bottom. I need it in the top. So I'm going to let u be cosine 4x. If you pick the wrong one, you'd go through and see it wouldn't work, and then you'd have to start back over. What would du be? Negative sine times 4 dx. So it would be negative 4 sine 4x plus 2 dx. Can you make that happen? Then I have to put the negative in front. So in other words, if I do a negative here and a negative here, I also need a 4, right? I need a 4 inside, which means I need a 1/4 outside. All right, so stay with me because wait. Yep, let me just rewrite it. Yes. Okay. I'll just rewrite what I got neatly. We made the whole bottom u. That's exactly right. It is. It's just du over u. What is the derivative of the antiderivative of du over u, or 1 over u du? Look at this. Mm-mm. Yes. Yes. This one comes up all the time. Anytime you have x to the negative 1, u to the negative 1, 1 over x, 1 over u, that's always a natural log. So it's negative 1/4 the log of u plus c. Du over u, remember all of this is du. All of this is du, this is u. Well, 1 over u times du over 1 is the same thing. How would you know what's 1? You literally should be able to go from this to this. I'm just showing you why.
Alright, Zach.
Du over u. Okay, du times u to the negative 1, Dozier. Listen, when you quickly dart your eyes away from me every time I look at you, it's so obvious. Okay. Does that make sense, Slade? Because u to the u is in the bottom, makes it have a negative 1 exponent. You are putting me in a precarious situation.
I'm calling a Sullivan and emailing Kirsten right now.
What?
I should email him the Miguel.
Okay. Y'all are getting caught up in, it's not even algebra. Y'all are getting caught up in the fraction rules. Okay, if I have 5 over 7, do you not agree that you could write that as 1 over 7 times 5? I did.
No, that's not right. That's not right.
Is he stupid?
Shut up, don't say that.
Are you stupid?
I see it.
That's not nice. Y'all be nice.
I got stuck.
Now do you see where this came from? And this. Okay. Okay.
It's just not good to you. Just have to learn to read a blog.
The log, if you look at your green sheet, the second one down, 1 over u. Kenzie, what part of that are you not understanding? It can't. We've still got to replace it. We're still not done. Everybody just got so stinking. All I have, look, the answer can't have a u in it. Ellen's right. This is negative 1/4. Ellen, cosine 4x plus 2 plus c. There is the answer. Okay. Let me just show you these couple little things because we got caught up on things I didn't. If I have dx over x squared, do you agree that I could write that as x negative 2 dx? And if I have dx over x cubed, it's x negative 3 dx. No, Kenzie's still confused about this. But if I have dx over x, then that is x to the negative 1 dx. Agreed? X to the negative what is, or actually let's start here. X to the negative 2 is what is a fraction. 1 over x to the negative 3.
Oh, Kitty, come on. Come on. Daughter of the head of the you're the daughter of a 2 times.
Not the same. 1 over u times du. 1 over u times.
That's our problem. Glasses. Get her glasses. Oh, I have them.
Find the antiderivative, Mark second.
Okay. Oh, okay.
That's too dang bad.
This one was going to
ln to the 6x is the same thing as this. This is an easy one. Y'all should get this.
it now. Is that our U?
I don't know, is it?
Yeah. Yeah, why not? Hey, I'm not gonna lie there. Oh wait, 1 over x. 1 over x.
Okay, so 18 through 24 give you the u to use. You don't have to find the u yourself. They tell you what u to use. It's not till you get to 26 that you have to find your own u.
18 through 26, and then.
You know what they say? Actually, let's go to 24 even, and then let's pick up 25, 26, and 27. Stop there. Again, these give you the u to use, so there's only 3 that you have to find your own u for. U into this. All right, what's your u here? It's the ln. How do you know to pick ln? It's the only thing you can take the derivative of. You can't find ln x if you let x be u. Well, it's okay. It stays because what this becomes is the integral of u to the 6th du. Everybody see where that du, that over x is the same thing as 1 over x. Y'all tracking with me? Antiderivative, what's the antiderivative of u to the 6th? I don't even have to put anything because everything's completely contained. Wait, antiderivative of, you don't have to do that. Because my du was 1 over x dx, and I've got 1 over x dx already in here. I don't need anything. The only time you do that, you have to make the inside, you have to make your du match what this du is. But you can only make it match by giving it coefficient. But this one didn't need one. Now, what's the antiderivative of u to the 6th? 1 over 7 u to the 7th plus c. Oh. Now I replace my u with my whatever my x was, which was ln x. So I got 1 over 7 log x to the 7th plus c. And we stop there. Yes.